we're going to have the same diagram as we had before. It is a toroidal shape. It has a rectangular cross section at its core. It has n equals 500 turns, and in its establishment of magnetic flux, and the current was 0.30 amps. The ferromagnetic material has magnetic flux, therefore traveling through it because of this magnetomotive force that was established. So there's a look at just one of the flux lines here. And this question is asking how much flux would be established in the magnetic path if the reluctance is this and the number of turns is, oh, we're going to switch that to 300, and we are going to switch the current to 0.18 amps, and we're going to change N to 300. So in this problem then, let's calculate what we would do. We take our formula for magnetic flux lines, and we remember that that's a ratio of the magnetic motive force that has been developed over how reluctant that material is for it to develop. We remember that Fm is equal to N times I. So we can change this formula to N times I over Rm, which is given. And that will now be 300 turns times 0.18 amps over the reluctance that is given here, 7.50 times 10 to the 3. And I'm modifying the question as I go, and I'm adding some significant digits to get 3 significant digits in this problem. And amp turns per Weber, I kept the turns, even though it's not a official SI unit. I kept the turns on the top and I kept the terms on the bottom. So when I calculate that, I get 0.072 Weber, which is going to be equal to 720 micro Webers. And so pretty simple problem. We have everything we have to go in there, and we can therefore just sub in and get the answer.